Asia. Welcome once again to this webinar, SWEP Refrigerant Outlook. My name is Erik Menke. I'm Manager for Regulatory and Public Affairs. I'm joined by Per Östberg, our Application Manager, who will present some of the information today. So, this webinar is about the regulations and protocols that will phase out HFC refrigerants the coming decades to decrease greenhouse gases. And for people that are new to this subject, it's about the vapor compression cycle, where we have the evaporator, the compressor, the condenser, and the expansion valve. And then we have the fluid and gas, also called a refrigerant, that is carrying the energy through the system. The current HFCs, and those are typical R410A, R407C, 404A, and 134A. These are being phased out right now in favor of low GWP refrigerants. And GWP stands for global warming potential. The higher number, the higher impact on the global warming it has. This presentation will cover an introduction about SWEP. I will cover the main drivers for refrigerant change, an application and refrigerant map. We will present a little bit about propane applications. My colleague Per will present SWEP refrigerant activities, what we are doing in this area, and conclude with summary and conclusions. And we will have a Q&A as well. The presentation will take around 30 minutes. And during the presentation, feel free to ask your question in the chat, since everyone is muted in this webinar. And some of the questions will be answered in the chat, and some of them will be answered in the Q&A session by me and Per. So, SWEP. We are a company. We were founded 1983 in Sweden. And we are a producer of brazed plate heat exchangers. That is our main product. Our headquarters are in Landskrona, Sweden, and this is also where we started almost 40 years ago. We are part of Dover Company, and we have more than 1,000 employees worldwide. We have 5 plants and 22 sales offices in Asia, Europe, and Americas. Moving on to the refrigerant change and the main drivers. Let's start with Europe. In Europe, we are guided by the Montreal Protocol and the Kigali Amendment, and this will drive phase down between 2019 and 2036, with totally 85% phase down. But on top of this, we have the F-gas regulation, which is a more aggressive phase down, at least initially. It will phase down 80% of the emissions between 2015 and 2030. We are following the EN 378 safety standard, which allow higher charge of A2L and A3 refrigerants in refrigerating system and heat pumps. We have also seen that the prices of 410A, 407C, and 404A has peaked, but they still remain on a high level. And we have a small graph down here illustrating this from the cooling post. So around 2018, we had a peak here, and it declined, and now it remains on a fairly high level. I would also like to mention the REACH PFAS regulation that might disqualify HFCs and HFOs. This is currently ongoing in the EU, and if the proposal is approved, and it's basically that the PFAS definition will be extended to also include HFCs and HFOs, there might be a ban on quite a few of these refrigerants 2025. Also important is the new F-gas regulation. The proposal came out this year and is currently being revised, and if approved, it will come into force 2024, and it contains a steeper phase down from the current regulation. It also contains bans that will affect some of the systems. United States, there the AIM Act, which is basically a derivative on the Kigali Amendment, drives the HFC phase down, and the next step in the phase down is 2024, where a 40% reduction will take place. The SNAP 20 and the US Climate Alliance and CARB has also defined several bans. Starting next year, January 1st, there will be a ban on refrigerants with a GWP higher than 750 in residential and commercial air condition and heat pumps. Also important, starting January 1st, 2024, there will be a ban on refrigerants with GWP higher than 750 in new chillers. So this includes R134A and R410A that are widely used in chillers. We have also seen that several A2L refrigerants have been listed as acceptable substitutes in the United States. So presently, we have 6 candidates, 452B, 454A, 454B, 454C, 457A, and R32 are listed here. But the building codes needs also be in place to use these mildly flammable refrigerants. And the new building codes is expected to be updated 2024, and those are necessary for the A2L refrigerants. Also interesting, we have the UL 60335-2-89 standard that includes higher charge limits for flammable refrigerants. This is in place, but it's pending the EPA approval, July 2023, and it will actually allow up to 500 grams of propane or R290 for commercial refrigeration. In this chart, we have listed the different phase down that will take place on a global basis. On the y-axis, we have percentage of phase down, and this is actually related to CO2 emission that have been converted to percentage. And the different phase down have different reference points, but in the EU, it's now taking place, as well as US, Japan, and Australia. What we can see here is that EU is by far the F-gas, the most aggressive phase down regulation. And right now we are here, 2022, and the next phase down in Europe will take place 2024. The gray line here is the proposed F-gas regulation, and you can see if it comes into place, 2024 will be a bigger step, and then eventually it will go down to 5% of the original going forward. So also long term, it's more a higher degree of phase down than the Montreal Kigali protocol. Then we have the non-A5 countries. In group 1, we have US, Japan, and Australia. And 2024 is the next year. The purple line is group 2 in non-A5, and here is Russia and Belarus and another 3 countries. The blue line is A5 countries, and here we have China, South Korea, and Brazil, among others. And the first phase down step will be 2029 here. India is in group 2, and here the first phase down step will be 2032. So some conclusions from this graph is that EU has the steepest phase down, followed by the other industrialized countries defined as non-A5. If we define 100% as an average GWP of 2,200, we can see that around 2024, we have an average GWP of 650. So this tells us in average that R32 and other HFO blends, that is medium GWP, these will be more difficult to use in Europe after 2024. And USA, yes, AMAC will have the next phase down 2024, and phase down in China, India is initiated 2029 and 32. Some drivers for China. Also, China has ratified the Kigali Amendment, and it's a total phase out of 80%, and it's starting 2029, and it continues until 2044. We expect 410A to be used domestically until 2029, when the phase down is initiated. Their safety standards, refrigeration system and heat pumps, it's denominated GBT 9237-2017. It supports mildly flammable refrigerant, and it's actually very similar to ISO 5149. In Japan, we will have an 85% phase down from 2019 to 2036. Already now, CO2, a natural refrigerant, is widely used for tap water heating in Japan. They have their own act on fluorocarbons and a revised F-gas law. They have some bans in place. I would say the ban in commercial air condition, where we have the VRF systems. There they have a maximum GWP of 750 from 2020. So in this case, for example, R32 is allowed for these systems. Coming to large-scale AC, that is chillers, there is no maximum GWP currently. And for safety, they also have the GIC 9335-2-40 standard, and also other JRI standard. Moving on to the application and refrigerant map, I have actually listed a number of different applications where BPHEs are widely used. So in the first column, we have air condition, residential heating, and refrigeration. Those are our own definitions. We have the application, how the BPHE is used, what refrigerant is used today, and typically the legacy refrigerant, what we believe will happen short term until 2024, and then what will happen mid-long term from 2024, and some drivers in the last column. Since it's a quite busy slide, I will actually focus on two applications here, the scald chiller and the air-to-water heat pumps. Scald chillers, here typically we see BPHEs used as evaporators and condensers. Up to now, 410A has been the most common refrigerant. And short term, we see a conversion to R32, 454B, and R290 as well. Mid-long term, that is after 2024, we believe that China will continue with R410A. We see that APAC will migrate to R32, but possibly also China. In the US, 454B will probably be a good candidate to replace 410A. We also see that this will be used in Europe. And we also already now see some signs of R290 being used, especially for air-cooled chillers in Europe. And the drivers here, once again, we have the AIM-Act CARB, we have the F-gas Kigali, we have the safety standards, and also eco-design that permeates low GWP. Moving on to air-to-water heat pumps. Here the BPHE is typically used as condenser in the monoblock system, and also as evaporator during those defrosting sessions that take place. Up to now, also here, 410A has been the dominating refrigerant. But the last years, there has been a quite obvious conversion to R32 and to R290. And we believe mid-long term, we will have R32 and R290 as the main refrigerants here. And this is mainly a European system, so F-gas and Kigali is the regulation that drives the conversion, and we have the safety standard 378 and the substandards to this. Some words about propane applications. For systems with a charge below 152, you can basically place them anywhere, and you do not need to take huge precautions for these. Here we see small display units in supermarkets. Quite often they are air-cooled, but we also see water-cooled, and here BPHEs is used as condenser. You can see one example here, for example. In supermarket display units, there is a possibility to use a charge up to 500 grams, 0.5 kilos. And this is governed by the standard 60335-2-89, and we also have a UL standard here up for EPA approval. And typically, they are being used in this type of system, display unit, and on the top there is one or several condensing units, typically using a BPHE as condenser. For exhaust air heat pumps, it's allowed to use up to 1.5 or 1 kilo, depending on what standard you're referring to. Typically, the BPHE is used as condenser, and we can see one example from NIBE here. And then lastly, for systems above 1.5 kilos, we see residential air-to-water heat pumps. Here we have one from Alpha Innotech, and it's typically a monoblock system where the full refrigerant circuit is placed outdoors. And it's governed by 60335-2-40, and you can have up to 5 kilos of refrigerant in that, or propane. Then we also see larger air-cooled chillers, and these have typically charge of propane above 5 kilos, and they are governed by 378. And typically they are placed in ventilated systems in restricted areas or machine room, which allow higher charge than in other systems. Here is a refrigerant matrix for reference use. I have placed the most common or the legacy refrigerants in the first column, 1, 2, 3 for low pressure. We have 134A for medium pressure, 410A high pressure, and then 404A high pressure as well. We have the GWP value here with AR4. We have the class, if it's flammable or not flammable, pressure, and then COP and capacity. And when you use this table, you should know that they're grouped. So for example, in the case of 134A, we have set 100% for these, and that is in relation to the 4 different refrigerants below. So in the case of set E, we can see that we have the same COP for a reference case, but we will have 25% less cooling capacity and 134A. So now we're moving on to SWEP refrigerant activities, and I will leave the word over to Per Östberg.
Yes. Hello, everyone. Now I'll take the opportunity to talk a bit about our refrigerant activities. And I would like to mention that in the SWEP heat transfer lab, we validate products to ensure we get the best possible performance and prediction accuracy. And we also have the possibility to test many of the low GWP refrigerants that has been mentioned here in the past slides. And furthermore, we have all BPHEs from SWEP tested in a standardized way. So we have a standardized thermal and hydraulic test that everything will go through. And we do this to ensure that we have a good performance model to build up. But then we also want to ensure that we can fine-tune the accuracy even more with new refrigerants. And we do that by doing standard chiller and heat pump tests. So we do that at standardized conditions for these applications. So we take the evaporator and condenser tests with different refrigerants, we take the data from those, and ultimately we will use the data to calibrate the models we have in our selection softwares. And the selection softwares is what you have on the slide here. So we have 2 of them. We have SSPG8, which is the desktop version that SWEP has been having for a very long time in different generations, so to speak. But we also have what we call the Thermex, which is an online version of our selection software. And I would say that these are equal in content and capability. So which one that you would use is pretty much a matter of taste. How you like to work, if you want to have it on your computer or if you want to work online. So all of the products that we test will end up in this selection software with fine-tuned models according to the refrigerant tests that we do. Let's see, I'll take control so I can switch slides. So this slideshow, I will present some products that work with these new refrigerants that we have been speaking about. And I would like to start with introducing the S range, which is our small range that will have capacities typically around or below 10 kilowatts. And the BPHEs that we have here are typically used in smaller residential heat pump applications. It could also be used for economizers. And here we have done proper testing with, for example, R32 and propane or 290. And you can see that I have presented 3 different products here. So the X4T, typical economizer that we would sell. We have the 8LAS, which is an asymmetric unit that can be used for condenser duties in smaller heat pumps. And then we also have the 8 double wall. That is a new product that we released quite recently. That is, it's a double wall. So it can have a good fit with some propane systems if you want to ensure that you can have some safety included in the heat exchanger. Then we have the medium range, which ranges from approximately 10 to 70 kilowatts. And here we have typically residential heat pumps and also chillers. For the heat pumps, normally condensers, and for the chillers, normally evaporators. But depending on the setup, it could be both, obviously, if they're reversible or water-cooled or air-cooled. And this is a popular range where SWEP is doing a lot of refrigerant activities. We have a good coverage of R32, R454B, and propane for this range. And a product that I would like to mention here is the 22AS, which we released earlier this year. It is a good product with propane that is having a good fit with high efficiency heat pumps, both as condenser and evaporator. And leaving the smaller ranges, we have the large range, which ranges from 70 to 300 kilowatts approximately. And here we would target larger heat pumps and chillers with these products. We have single circuits and we have dual circuits here as well. And when it comes to the larger range, we don't have the same need of propane at the moment, and that is pretty much explained by the earlier slide that you need to take some precautionary actions if you want to have a large charge of propane in the system in some cases. But the idea is that we will also perform propane validations with this product in the near future. And I would also like to present this TW250AS, which is using the same format as the 250AS. That is a legacy SWEP product that we had for quite some time. But the TW is standing for our Hypertrain technology that we released 2021. And with Hypertrain technology, we can offer best-in-class performance for reversible systems while having a low refrigerant charge. And there are also other advantages with this product. And if you want to read more about it, you can find it at swep.net, where it has a landing page called Hypertrain. And then I'm coming to the last range here I want to present, which is the XL. We have an XXL range as well, but normally it's not used with refrigerants. And since we're talking about refrigerants here, I would like to present some of the activities we have here on the XL, which is done from approximately 300 to 700, I would say, kilowatts. And here I've mainly been focusing on the 14A replacement refrigerants, which is then mainly R32. And we also intend to do some tests with the 454B going forward. I can also mention that many of the products that we have here are obviously tested with other refrigerants as well, 14A, for example, and it could be others that are also tested. Yeah, and then I would like to hand the word back to Eric for a summary.
Yes, thank you, Per. Excellent. We have some questions here related to your material, but let's save that for the Q&A session. All right, to conclude this webinar, starting with Europe, EU has the steepest phase down, followed by other industrialized countries defined as non-A5. We see that R32 and medium GWP refrigerants, typically R32, will be difficult to use in Europe after 2024 when we have the next phase down. But we see that 454B can be used a little bit longer since it has a GWP of 466. It's actually below the average GWP of 2024. R290 propane, we predict that to be a long-term solution for several applications, especially air source heat pumps, air-cooled chillers, and commercial refrigeration, where it's already widely used. We see very strong trends towards R32 and R290 for air source heat pumps, while the trends for ground source heat pumps are still unclear. And just a comment here, the reason is, of course, that air source heat pumps is placed outdoors, and it's much easier to mitigate the risk of a flammable refrigerants compared with bringing it indoors. United States, a lot of things are happening here quite soon. We have the AIM Act that will have the next phase down 2024. We will also have the bans. There will be new building codes in place, and that will support the use of A2L refrigerants. And maybe the most important for us as BPHE producer is that new chillers, 410A and 134A, they will be banned from 2024. And right now it looks like it's going to be replaced by 454B, R32, and R513A. More can come, of course, but this is what we think is visible right now. In China, the phase down will be initiated 2029. We believe that we will see 410A on the domestic market until 2029, while low GWP-based system will be offered for export market. So with that, we move over to the Q&A. And we have already answered on copy of the presentation that will be sent out, yes. And then we have one question here from Emna Delali. I think it's a question for you, Per. When the case evaporator condenser is cross-checked, it means that the model could be selected for a reversible heat pump, question mark.
I'm not exactly sure what is meant with cross-check here, but maybe we can go back to the product slide 11.
Yeah.
So when it is checked, it means, yeah, indeed. So when it's for evaporator and condenser, it means that there are validated products with these refrigerants for both evaporators and condenser in this range in question. So in the S range and in the M range, we have full coverage of propane with evaporators and condensers, but we don't have that yet in the L range, if that answers your question.
And we can add that, as you told before, all kinds of refrigerants can be calculated in our software, but
yes,
since we cannot test everything, most of them will be based on theoretical calculations. But
yes.
in these cases, we calibrate it with test data, so they are more accurate.
Yes.
Right, we got the question from Mervyn here. Can you link to the online selection program?
Yes,
we have
I have done that.
Okay, great. Thank you,
Yeah.
Per.
We have everything on the SWEP.net homepage. You can find both the desktop version and the online version if you like to.
And we can add here as well that both softwares are using the same calculation engine, so there is no difference in the predictions. It's more that if you choose the web-based, you get the most recent interface, and you also avoid problems with firewalls and allowance from IT to install software on your computers. If you're in a company, that is quite common. Then we get the question from Ottman. How about 455A, A2L? Are you also approved also? Let me see, 455A. Yes, we have it here. So it's a low GWP refrigerant. It's A2L. We have not tested it in our laboratory, but it's possible to do the calculation in our software, right, Per?
Yes.
Yeah. We can mention here that it has quite a big glide. We see some customers trying it out. There might even be some products out on the market there, but for reversible system, it's always difficult to have those big glides. Yes. So I think that was the last question in the chat forum. No, here is one more from Mirko Fasolo. Have you done any test with 5134 yet? Yeah, go ahead.
No, we don't. We have not tested that yet. It's in this list, as you can see, number 5 from the top. But it's
Right.
also something we have not tested yet. It has not been in focus or priority.
What I have seen in literature is it's very similar to 134A. It's I think it is a drop-in to 134A, and it has a GWP of 631, so it's typically something you can use medium term. I think it's probably something that is chosen. I already see it from some customers in the United States. Even though it's theoretical, it's probably very similar in our software to 134A. Okay, moving on to Luca Di Donato. Is it possible to know which refrigerants have been actually tested and which have been theoretically modeled in the software? Per, it's a question for you.
Yes. So one way is to ask SWEP, obviously, but otherwise I would say that many of the products that we, for some reason, think will be not accurate in our selection software will also not be available for you to calculate, I can say. So we do some, damage control there before we make something available. So for many new products that we release, they might not be open for calculation with all refrigerants because we have not been able to do this check or control on them yet. But if you check on older products that we have out on the market for maybe 15 years, it will be different. They will be able to calculate with many of the refrigerants that we also have in the software. So if you can calculate it in our selection software, you will not know if it is tested or not, but you will know if we consider it to be a risk or not. That's one way to put it.
Yeah, and we can also add here that if you're unsure about your own calculation, feel free to reach out to me or to Per, and we will take a look at the calculation and see if there is something that should be considered there with the particular refrigerant. All right, we also got the confirmation here from Vincent Schrapp that 513A is a drop-in for 134A. So thank you for that comment. Okay. No more questions, so I would like to thank everyone for participating today. It was great fun presenting this material. Per, thank you for contributing here, and also Helene for helping out here, and we will provide you with the presentation as well. I don't know if it will be mailed out or available on the site, but you will get it somehow. So thank you very much and have a fantastic holidays, and goodbye for now.
Thank you.